Okay, in this problem, we want to basically determine the magnitude and direction of the resultant force. Basically, take these three forces and add them together. And the way that we're going to do that is we're going to break them all up into their x and y components, or their horizontal and vertical components, then add those horizontal components together, add those vertical components together to get the resultant force. So we'll go ahead and start with F1. And what we're going to do here is we're going to break this up into its x and y components. Essentially, I'll have a y component and an x component like this. So basically what I'm looking for here is this is my x component, this is my y component. Now, the way I'm going to do this on this problem is going, or on this triangle here, is I'm going to use similar triangles here. You'll notice I've got this triangle right here that um, I'm looking at, okay? And what I want to do is I want to set that up in such a way that it's the same as my bigger triangle, right? So essentially what I've got is I'm going to take and I'm going to say, okay, well, uh, 60 relates to the square root of 2, right? Just like fx, my x component, relates to 1. Right? So I'm using the hypotenuse of each triangle ratio and then the horizontal component of each triangle. From that, I can find, okay, well, if I'm using similar triangles, hopefully you've done this before, I can find that fx is actually 42.4. And I'll do something very similar. The other way you could do this is say, okay, well, I can, I can say that something along the lines of like 1 over the square root of 2, basically take the smaller triangle. So I've got my horizontal, I'm sorry, my vertical component over its hypotenuse equals my unknown vertical over my known hypotenuse, 60. Okay, either way will work. From this, I will find 42.4. And again, those should be equal because they're both equal to 1 on the similar triangle. So you set up those similar triangle ratios and you can find those components. Now, the way that we write those components is like so. So to find that force in Cartesian form, I'm going to say, okay, 42.4 in the I direction, where the I direction it represents my horizontal or my x component. It's a unit vector, has a magnitude of 1 in the direction of my uh, x-axis. Now, that is actually pointing to the left, right? You see that the arrow is pointing to the left here as this F1 vector goes to the left and up. So it's actually pointing in the negative x direction. So I'm going to throw a negative out in front of that. Whereas my y component is up, so that'll be plus 42.4 in the j direction, or j is the unit vector in the y direction, so it has a magnitude of 1 in the direction of y. So that's how we write a vector in Cartesian form. That would be negative 42.4i plus 42.4j. That means it's to the left 42.4 and up 42.4. Okay, now we do it a little bit differently for when I have an angle like I do for F2. Okay, same idea here is I'm trying to determine this triangle here, right? I've got my y component right here and my x component right there, right? That makes up breaking that 70 pounds into horizontal and vertical components. Okay, now I'm going to use that angle of 60 degrees to figure this out. Now, knowing that what sine and cosine are, if I want to find f of x, notice that's opposite of that 60. And you'll remember that sine is opposite over hypotenuse. So if I say the sine of 60 equals that opposite, that would be fx, divided by my um, uh, f2, again, this side right here, my hypotenuse is 70. Okay, so the sine of 60 is um, opposite over hypotenuse, which would be fx over 70. From that, I can find that fx is then 60.6. And we'll get the direction in a second, right? We're just finding magnitudes right now. Similarly, the cosine of 60 is adjacent over hypotenuse, where the adjacent is actually my Fy all over the 70. From that, I can find that my y component is then 35 by solving for Fy. So to write this in Cartesian form, I say, okay, in the x direction it's 60.6, but I notice that it's to the left. Again, positive is to the right, negative is to the left. So I say negative I, and then I've got 35 in the j direction. It's acting downward, right? Positive upward. So this will be negative j, like so. So that's how I set up those uh, components using an angle. Now, F3 is acting straight down. So there is zero component in the I direction. So I only have my j component here, so I will say negative 50j. And again, it's negative because it's pointing straight down. Okay. So now I've broken each force, or I've written each force in Cartesian form, right? An I component and a j component. So now to find my reaction, or my resultant, I should say, in the x direction, I just add up all of my x's, which is going to be negative 42.4 minus 60.6 plus 0. Again, 0 because F3 has 0 component in the x direction. Adding those all up, I get negative 103 in the x direction. So that's the component of the resultant force in the x direction. I'll draw a picture here in a second once I find my y component, which is the same idea. We just add up all my y components. So 42.4 minus 35 minus 50, and I get a y component of negative 42.6. So what does this mean? Okay, well, I can write my resultant force as negative 103 point, no, there's no point, sorry. Negative 103 in the I direction, minus 42.6 in the j direction, okay? And then the magnitude on this will be pounds. So what am I looking at? Well, if I look at my xy axis like this, what that's saying is I've got an x component of 103, a y component of 42.6. So if I finish off my quadrilateral parallelogram, which here is a rectangle, my resultant force is actually in that direction like that. Okay, so that's the picture that I'm creating there. So this is one way to write the answer. This is the answer in Cartesian form. Of course, the problem is asking for the magnitude and direction. So I need to find the magnitude of this. Well, this is just a right triangle now. So this is just Pythagorean theorem. Very easy to find the magnitude. Just going to be the square root of the sum of the squares. 103 squared plus 42.6 squared, like so. That gives me a resultant force of 111 pounds. Okay. I can find any angle I want. I'm going to find this angle. It's important to define that so we know what we're looking at. Now, again, I know the opposite and the adjacent, right? This opposite sign is 103, right? So we just do an inverse tangent to find that. So an inverse tangent, or an arctangent, you have this on your calculator. Again, when you solve this, you want to make sure you're in degrees. That's going to be opposite over adjacent. So that's going to be 103 divided by 42.6. And again, you know, tangent of an angle is opposite over adjacent. So the inverse tangent of that opposite over adjacent will give me what that angle is, which once I do that, I get 67.6 degrees. So the other way that we can write this result is 111 pounds. That's the magnitude. And then the angle, and the angle that I'm looking for is this angle right here of 67.6. And again, it's always helpful to put the little picture there to show everybody exactly what angle it is that you're talking about. Now, these two ways to write it are the exact same solution, it's just different ways of writing it. Either is fine, unless, of course, the question, as it did here, asks for both the magnitude and the direction rather than the answer in Cartesian form.